All right, IM2 classes. Today, we are talking about the quadratic formula. So we've learned a couple of different ways to solve quadratic so far. If it's a basic quadratic, you can solve it using square roots. If we get into quadratics that are trinomials, they have three terms, an x squared and x in there. You can solve it by factoring, or you can solve it by completing the square. This last method, the quadratic formula, you can solve it. This method works no matter what. So, for example, if you have a quadratic that doesn't factor, obviously you can't factor it to solve it. And sometimes, if you're dealing with a lot of fractions or whatnot, completing the square can be more difficult than it's worth. The quadratic formula works for everything, whether it factors or not. You can use the quadratic formula to solve a quadratic equation. This is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When I was in school, I had to have this memorized. I'm not expecting you guys to have this memorized. We're a little bit more evolved than that now. You can write these things down. You can look it up if you have to. It's fine. But it's important to know how to use it. So the A, B, and C all come from the quadratic formula. And this is for if we have the polynomials with degree of 2. Before we get into actually using it, we are going to do the discriminant first. The discriminant is this part that's underneath the radical. I like to do just that first, because that will tell us how many solutions the quadratic has, and if we actually need how far we need to do in there. So a quadratic can have 2 solutions, 1 solution, or no real solutions, and we can figure this out depending on whether this is positive, 0, or negative. So if we look here, determining the discriminant here, if the discriminant here, this is positive on this one, if it's greater than 0, if it's positive, you can see it will have 2 solutions, where the solutions are where it is crossing the x-axis there. Those are the 2 solutions. If it's equal to 0, it only has the 1 solution right there, right? And then if it is less than 0, it has no real solutions. It is not crossing the x-axis, so it's no real solutions. We're going to get into imaginary solutions in the next lesson. We're not going to worry about that yet. Right now, just no real solutions. So just a quick reminder of where the A, B, and C come from. So A is attached to x squared, B is always attached to x, and C is always by itself. So let's get to this here. So how many solutions does this have? First thing I'm going to do is identify the A. So A is 2, B is 5, right? Weird looking 5 there. And nope, C is 6. Almost did B twice. I'm going to use the discriminant. Again, the discriminant is b squared minus 4ac. What I do is I replace the A, B, and C with parentheses, and then fill it in. So first, A, be careful where you put in the A. The A goes in here. Normally kids go A, B, C, but it's B, A, C. So just pay attention to where you're putting things. Next, we have B is 5, so that's going to go here. And then C, do that purple. C is 6, that goes here. All right, just make sure you're putting stuff in the appropriate spot. And then evaluate this. So 5 squared is 25 minus 4 times 2 is 8 times 6 is 48. So 25 minus 48 is negative 23. Since there's negative 23, that means no solution. That's it. No, I guess I can put real solution, because we are going to talk about non-real solutions tomorrow. No real solution. Might as well do another one. Pay attention to here. How many solutions does this have? This is out of order. 3x squared minus 7 minus 4x. I almost caught myself with that one. So 3x squared, it should be minus 4x minus 7 in the correct order. So it should go x squared, x, and then no variable. And so now when we identify our A, B, and C, makes it a little bit clearer, right? So it's, again, the discriminant is b squared minus 4ac. So b minus 4ac, and let's substitute things where they belong. So a is 3, that goes here. B is -4, so a -4 goes in here. And then C is -7. I did parentheses -7. I don't know. That's C. Anyway, for this one, it helps to keep track of the negatives if we change this minus to plus a -4. That'll make more sense when we're multiplying this stuff out. So we didn't do that in the last one because it's all here, but it's a lot easier to keep track of all the negatives if you change it, this minus to plus a negative. All right, just trust me on that one. -4 squared is positive 16. Bring down the plus, and then it's going to be -4 times 3 is -12 times -7 is a positive, positive 84. Yeah, -12 times -7 is positive 84. So here, keep track of the negatives. So now when I add together, 16 plus 84 is 100. So that has 2 solutions. And that's it. So we're going to skip ahead. This one's going to have 0. See it. We're going to do the full quadratic formula now. I'm still going to start off with the discriminant. So it's still b squared minus 4ac. And I hope that if you write it out every time you use it, you remember it a little bit better. So b squared minus, oh my God. I don't know what's going on with PowerPoint. It does not want me to write a nice A, 4ac. So I need to identify A is 9, B is -8, C, since it's minus 13, is -13, and it's starting off with that discriminant, b squared minus 4ac. Again, substitute things appropriately. So A is 9, that goes here where the A is, right? B is -8, so that's going to come here where the B is. And then C is -13. Nope, wrong one. -13. So here you get, I'm going to change this to plus a -4 just to help make things a little bit easier. I'm going to need a little calculator. This one. But -8 squared is 64 plus -4 times 9 times -13. That comes out to 468. And then add that together, you get 532. All right, so here I can do the, can't move it all. Oh, nope. I can now substitute into the quadratic formula. X equals AB plus or minus the square root of b squared minus 4ac. What I'm going to do is just rewrite it, the quadratic formula, and just put in parentheses for everything that I need to replace. So the discriminant, the part that's underneath the radical, the b squared minus 4ac, I already calculated that, so I don't need to do it again. So 2 times a. So Already calculated the discriminant, that is 532. So I don't need to do it again. B, that's going to be a -8. And then A is 9 on the bottom. So we're going to go ahead, simplify that. So the 532, you can do buddy system. I'm going to do a factor tree over here. 532, that splits into 2 and 266. 266 splits into 2 and 133. Divide that by 7, so that's then 7 and 19. PowerPoint does not want me to have good things. So that 532, if I do 2 times 2 times 7 times 19, I have a pair of 2's, so 1 on the outside. So that's going to simplify to 2 times 133. Here, a -8 is a +8, plus or minus. This reduces to 2 times √133 over 18. I can reduce this a little bit more. Actually, if I, what's the easiest way to do this? All right. So you can reduce, since these are both divisible by 2. So if we look, I can reduce the 8 and 18 and the 2 over 18, since they're both divisible by 2. So this is going to be 18. It's going to be 9 on bottom, and then 4 plus or minus √133. And that is as simplified as we need to take it. Let's do one more. Yeah. So identify your A, B, and C. Oh, actually, you know what? We're going to skip ahead to this one. So this isn't in the correct order. So we need to put it in the correct order. So we have 3x squared minus 10x plus 4 is equal to 4. And so we need it in actually standard form. So I need this 4 over on the other side. That's not how I wanted that to work out, but okay, whatever. So minus 4, so it's going to be 3x squared minus 10x. That's supposed to be a minus 4. That's a really long minus sign. Equal to 0. And we did that just to get everything on one side. I can still work this out using quadratic formula. So A is 3, B is -10, and C is 0. Since there's no term there, we just put it as 0. I'm going to start off with the discriminant, b squared minus 4ac. So it's going to be b squared minus 4 times a times c. So make this a little bit easier, because it's going to be b is -10, a is 3, and c is 0. So 10 squared is 100. This is all 0. This is 100. Just a hint, if this ever works out as a perfect square, like it just did here, you're going to want to solve it by factoring. We could have factored out an x and solved it. It would have been much easier and quicker, but we're going to do the whole thing here. Next, I'm going to do the quadratic formula over 2a, and I'm just going to substitute in the pieces that I need. I already found 2a. So b is -10. The discriminant we found as 100. And a is 3. So we get -10 is a +10. Plus or minus the square root of 10 is 10. And then 2 times 3 is 6. So since these are all whole numbers, we can separate out this plus or minus and then simplify it all. So it's going to have two solutions. It's going to be 10 plus 10 divided by 6, or 10 minus 10 divided by 6. So we can do both of them. 10 plus 10 is 20 divided by 6. This is going to work out to reduce that. Divide top and bottom by 2. This is going to be 10 thirds is one of them. 10 minus 10 is 0. Divided by 6 is just 0. So 10 thirds and 0 are our two solutions. That will do it for us this time. Next time we're going to talk about those imaginary solutions.